Today we're going to be talking to you about a project that was done at Land O'Lakes in Pine Island that spanned over a few years, that modernized the plant. And with that modernization, we were able to increase throughput and cut out some days of downtime because of it. So my name is Tim Barthel. I'm with Cybertrol Engineering, and this is Esden Schreier. He's with Land O'Lakes. So what we're going to do is, first of all, we're just going to talk a little bit about who we are, what we do, a little bit about our companies, and then we're going to go into the business challenges that Land O'Lakes had that required this modernization. We're going to roll then into the path of success, which basically we're going to break down all those challenges and then the solutions that we came up with to get a successful plant. We're going to talk about the benefits that were realized because of all of these improvements that were done, and then just kind of finish up with some of the next steps we're performing at the plant as continued improvements. So with that, I'm going to just let Esden talk a little bit about Land O'Lakes.
All right, hello and welcome again, everyone. So I'm Esden Schreier from Land O'Lakes. I'm going to give you a little bit of a background today on Land O'Lakes as a whole. So a lot of you might think of Land O'Lakes as just the Indian on the butter, but we're actually a well-diversified company. So we're broken up into different divisions. We have our dairy foods, crop inputs, and feed. I'm currently based out of the dairy foods division. The dairy foods division is comprised of 11 facilities. We stretch all the way from California to New York. I'm currently based out of the Pine Island, Minnesota facility. We specialize in the production of cheese powder. So we have 2 spray dryers that run 24/7, and we also have a dry blend supply line. The cheese powder, if you think about it, just think of any sort of your kind of snack foods, like your popcorn or your white cheddar popcorn, your Cheetos, anything of that nature. I've been with Land O'Lakes for 6 years, going on 7. I started out as a temp agent, where I actually was hand stacking bags at the time before they got a robotic palletizer. Then I moved up my way in through operations, moved over into maintenance, had several roles there, where I moved into the maintenance supervisor position and now the maintenance manager.
I've been with Cybertrol Engineering 9 years, and we are a controls and information systems integrator out of Plymouth, Minnesota. We do work nationally and internationally, just anywhere from, we do food and bev, med device, oil and gas, quite a few different industries. We're a Rockwell solution partner with the control, process, and information areas. We also have a very strong group of networking and server infrastructure, so we will do projects anywhere from a new greenfield plant design all the way down to a 1 or 2 day project for a customer just to help them out. Over the 20 years we've been in business, we've done thousands of projects for over 400 clients. So now we're going to go into some of the business challenges that Land O'Lakes had.
So with this, what you guys will see is we did 2 sets of upgrades. So we did a system upgrade in 2009 and another one in 2014, so we'll break down each of those. So starting in 2009 and prior, we had a legacy PLC and HMI system. So with this system, it was unsupported. It was unsupported locally at the plant level. We didn't have anyone internally to help out with it. We relied heavily on the use of outside contractors to keep us up and running. With that, the old PC the PC was based on a Windows 2000 system. Windows 2000, as several of you know, was not very reliable, had security issues, and it did not support RDP sessions. Without the support of the RDP sessions, it caused the contractors to have to physically come on site to troubleshoot any issues. As you can imagine, that causes a lot of plant downtime. Once you actually call and get a hold of somebody, then you have to wait on their travel time to get down to your facility, let them in, and then get them in and going. The batching system was proprietary and was unsupported by the system developer. We tried to support it at our corporate office. What we quickly found out is that we were not batching experts by any means. We were putting several patches on the system and just trying to limp us through to get the production out the door. We also had a linear batching system. So with that, each ingredient had to wait on the previous one to go in. Only one ingredient could go in at a time. We had multiple ingredient lines that were going into the slurry kettles, but they weren't all being utilized. The operators also had hand-entered values. They'd physically have to go up to the HMI screen, type in and manually transfer over all that data and download it to the PLC system for it to take it in. Through these two items, it was time-consuming, and by the time-consuming part of it, the operators were always trying to get the production out the door. With that, it caused them to have to manually bypass things several times. They would start putting valves, pumps, and manual, anything that they could do to keep the operation running. It doesn't make sense to have a batching system if your operators constantly have to run things in manual, so it defeats the whole entire purpose. There was no visibility into the operations. Our schedulers would have to walk out on the plant floor 2, 3, sometimes 4 times a day just to see where they're at in the scheduling operation, just keep up with the day-to-day tasks and keep up with our corporate office as well. And we also had no data collection available at that time. All we had was hand sheets where operators would physically write down everything that they did, file those sheets in a central location. Then if you wanted to pull any of those data or records, you'd have to go back to that central location, pull them out in hopes that the operators updated the sheets. Continuing on into 2014, so we saw some system improvements from 2009, but once we got to 2014, the system was starting to get slow. It was outdated and unsupported. Again, it wasn't supported internally by anyone in our staff. We had the use of Windows XP FAT clients that were out on the plant floor. Those were starting to become outdated and unsupported as well. The operating systems were Windows 2003 and Windows XP. The software versions were not kept up to date with technology. So with that, to update any of the software versions, we had to cause plant downtime. With that, you guys can imagine they wanted to get production out the door, so if you say you wanted to upgrade the software, it wasn't a good enough cause to down the production at that time. We needed an increased visibility inside our plant. So after 2009, we started getting some data back and analysis. With that, once you start getting all your data back, it starts to become a bit addictive. So you're starting to find your factory inside the factory. With that, we wanted to get even more out of it and optimize our process. So then we started to focus on the process optimization and energy optimization. So we wanted to start looking at that into more savings. We have a sister plant that is internal in Land O'Lakes, so it provides some healthy competition for us. We wanted system monitoring to reduce downtime with the use of data collection. So we wanted to figure out where our downtime causes were by the actual data. Let the data tell us what is going wrong in the system besides all the hearsay. A lot of the time, whenever we were troubleshooting an issue, we would have multiple trends pages up just to see what was actually going on in the system and what occurred at that time. So now on to our path to success. So again, we had our 2 upgrades, 2009 and 2014. So starting off in 2009, we upgraded to the FactoryTalk and ControlLogix platform. We went from an old, outdated legacy PLC to a ControlLogix PLC. The batching system was upgraded to FactoryTalk Batch. The HMI system was upgraded to FactoryTalk View SE, networkly distributed. The reporting interface, we added a local historian, and we implemented the use of Vantage Point. So then moving on into 2014, so we went with the server upgrade. So we went from the physical to virtual server upgrade. We implemented a SAN infrastructure. The software and operating systems were all completely upgraded. And with that, we were able to add on visibility and support additions. So now breaking down in depth some of our business challenges prior to 2009. The process hardware in the legacy PLC system, so failures were becoming common. The legacy system that was out there was no longer supported. It was getting harder and harder to find spare parts. Obviously, for our company, eBay is not a preferred vendor by any means, so that causes you to have also a higher cost of ownership. You have to stock more spare parts. Our parts room was growing and growing, and we had a lack of standardization. Also with that, the PLC code was undocumented. On top of that, it was a DOS-based programming. So if you can imagine anyone coming in from the outside, you're basically opening up a blank template to try to figure out what's going on in your process. Sometimes it was something as simple as a proc switch or a switch was flipped in the wrong area that you didn't know about. But if you went in the PLC code to try to troubleshoot it, it was like running blind. So you'd have to pull out the one-line diagrams or the wiring diagrams, everything of that nature, just to try to figure out what's going on in the system. And then, of course, the internal support was lacking also. The PC operating system needed updating as well. So the HMIs were all on a PC-based system. So one change required updating all PCs. As you can imagine, that didn't always happen. As you're on the run trying to go and do things, only certain PCs would get updated at a time. There was no shared resources of the screens. With that, you could walk up to several different HMI stations and you would see different pages. Like I said, we have two spray dryer systems. Both systems are set up fairly similar. And you could look at two different operating screens which were right next to each other and they'd be completely different. You could see the challenges with that. Operators coming in, filling in for overtime, anything else. They come up to a brand new screen. They have no idea where their usual controls or anything else is at. There was no system redundancy. So with the PCs, if the PC went down, any changes that were made to those PCs, if it was lost and it went down, it was completely lost. We didn't have any backups of it at that time.
So this is an actual picture of their plant. You can see that it was really dark days for the plant with all that low legacy hardware. So what we did is we worked with operations and came up with a plan on how to upgrade the system one process at a time. So we designed a plan to get rid of all that old infrastructure from the PLC and HMI side and bring in new. So we would take one area of the process at a time, upgrade that logic, get the HMI running. We had some things kind of running in parallel and slowly migrated the plant onto the new platform. And we did this using Rockwell automation, the FactoryTalk platform there. And so with that, we talked to operations, saw how they ran the system, and saw where we could do process improvements in their PLC programming to make more efficiencies of the system. So specifically, there was 5 legacy PLCs, and we converted that into 2 control logics. So this made a lot of ease of use of the programming because there's less messaging between multiple controllers, and we were able to standardize the programming into a readable format that was commented good, so troubleshooting was a lot easier with it. HMIs, we put in a server-based FactoryTalk View SE system. So if we made the changes to one of the screens on the server, it's transmitted out to all the different clients out on the plant floor. So you don't have to worry about making a change to one and then moving that file to each one of the stations on the floor. And it was a redundant system, so all those changes that you made get stored back to the secondary one. So if you do have a failover, you stay up and running and you don't lose those changes. For the batching process, it was a standard S88 solution using FactoryTalk Batch. We wanted to make it so that anyone could support this if they know the Rockwell platform, either from Rockwell or other system integrators that are familiar with the batching process, so that Land O'Lakes isn't reliant on a single source for this matter. For the historical data, we put in FactoryTalk Historian SE. Previously, they had local data logging only at each of the client stations. So if you wanted some of the data, you would have to go to the station that was logging that data. So it was not very efficient to look at some things. And then for visibility, we put in Vantage Point for looking at trends, dashboards, and some of the reports that we're going to show you a little later.
So continuing on in our business challenges prior to 2009. So with the batching system, it was on the proprietary system. The system was operated on clipboards. The operators would go up, get a sheet of paper with the current batch that they were going to run, then they'd go up and they'd manually enter in those values. So when they entered in those values, the way the PLC code was set up and the communications on it, there was times where it would take up to 30 seconds for it to physically load, and at other times it would fail. So what the operators would do would try it 2-3 times. If it wouldn't work after that, they'd begin the manual intervention. As I brought up before, there's no sense in having a batching system if it's not reliable and your operators have to continually to run things in manual. The source code was not available for editing, so with that, the code was buried deep down in the PLC. There was no easy way for changes. With that, our R&D group, if they wanted to come down and run any R&D batches whatsoever, it'd cause us to have to go into the PLC code and make major changes, which wasn't effective whatsoever. We had no way of changing groups, parameters, anything else like that around. We were stuck with what we had. The inefficient method of loading recipes and editing them. So what they had to do is they had a corporate computer that sat on their network because we kept everything separate. They would then take the recipe from there, switch it over to the operations network where that would then be given down to the operators. So there was the inefficiency of the constant back and forth and trying to get that information. And again, the linear operations. So we had approval from corporate to dose in multiple ingredients at the same time. We had the slurry kettles all pre-set up for that for multiple ingredient lines going in, but the batching system at that time would not support it.
So, as I said, we put in a FactoryTalk batch system, and this is kind of how we implemented it. We made a very flexible recipe that could take all of their different recipes, whether they're R&D recipes or their standard ones, and fit them into a template that would break things up into different groups for the ingredients that needed to go in. So we built a web interface that took the corporate recipe, which was Excel-based, and converted that into a format that could download directly into that standard FactoryTalk batch recipe. So it load all the parameters in there, and it allowed them to put a schedule together as well for the production floor to see, either in a campaign format or one at a time, however they wanted to do it. So from the office, they could control how they wanted their recipes to be and push them out to the batch server. At the HMI, out on the plant floor, they had the same visibility to whatever the scheduler put out there. So they're able to see all the recipes that are on their list and start them one at a time as they needed. But they also have the ability to add another recipe, to schedule one right from their HMI if they need be. If, for example, they needed to add one more batch into the system. Okay, then once they start it from the HMI, it communicates with the PLC on the plant floor. You know, that communication between batch and the PLC just happens. It pushes down the ingredients, the set points, everything that happens that has to run on the plant floor. And while that's occurring, the PLC is continually feeding back data into the batch server for storage into SQL, into event table. That event table is then used for information for everyone to see at the corporate level. So we're able to combine the historical data that's happening during the batch along with the specific event data that happens within batch and combine it into one report that they can see everything that's happening throughout the operation. So as been mentioned, the linear operation. When we built this recipe, we put in a lot of parallel operations so that multiple ingredients can go in at the same time. This is a huge time savings. If you can add 3 ingredients in the same amount of time instead of just one at a time, you're saving a lot of time. So we did it by, as I said, multiple groups. So if they did have certain orders they needed to have things go in, you could have group 1, 4 different ingredients go in, group 2, maybe 3 or 4 go in at that time, but then you still get your sequence that you need, but you can schedule it a little better and save time doing it. Also, when we implemented this, we talked to the operations and saw what they were doing, and we saw they're jumping between a lot of different screens. So we developed a easy operations screen for them to use where they could see their batch process, what's currently happening, what's the transition, what are they waiting for, and as well as all the ingredients going in one place so that they don't need to jump between screen and screen, and they're not just looking at a screen with tanks and valves and aren't tempted to start opening valves in manual to make things happen faster or in another way.
So continuing on in the business challenges prior to 2009, so our CIP system, or the clean in place system. The cleaning system was very inefficient and difficult to make any changes. It was the exact same as the batch codes, so all the changes had to be made deep down in the PLC. With that, if a new circuit wanted to be added, we didn't have the support of adding that on, so what we'd do is just have operators basically end up using the same recipe as originally. Then what they'd have to do is manually turn on valves or reroute the CIP system in and through. As you can imagine, that causes some issues between interlocking with your process and your CIP. It had no way of knowing between the CIP and the process if they were currently making a batch or not, and between the CIP system. Several of our CIP connections, they have 6 or 7 connections. So with that, we had no proximity switches on there as well. So you had to rely on the operators hooking up every single connection right. That way you didn't end up sending CIP solution into the silo or somewhere else that was holding an ingredient that would then have to get dumped down the drain. There was no visibility in the sequence or the pulsing. So for the sanitation manager, he had no idea what was going on besides physically walking out on the floor. So he would have to go out and track to see which valves were pulsing, moving, and where all the flows were going, along with having a clock there to see his times and his set points. He didn't have any use of like a CIP pin chart for validating or for using whenever our chemical providers come in to trace back to.
So we migrated this into FactoryTalk Batch as well. We combined it with the process. So what we could do is interlock at the server level the operation in the CIP. We had that arbitration in there. So we were sure at the server level and at the PLC level that a cleaning process wasn't happening on a line that was in process. So it's easy to see with the SFC, the function chart that's there, for the sanitation managers to see the steps that are occurring within the CIP, and then they're able to actually make changes fairly easy as well here. So they can add steps, move steps around, and it's all easy to see in there, along with the pin charts that we made for the specific device controls. And then using Batch View, which is a tool that's part of the Batch suite, you can see the actual operation that's occurring of that CIP and what transitions are going to occur. So if you're troubleshooting the circuit, not sure why it's not moving on to the next thing, you can see exactly what's happening there. And we're able to use that information directly on the HMI so the operations are aware of what's occurring during their CIPs as well. And again, because of the standard reporting that, or the information that reports from the PLC to the SQL table in Batch, we're able to get Vantage Point reports that, again, combine the historical data along with the event-based data to create good CIP reports that allow them to optimize their CIPs and see how they ran.
So continuing on, so the business challenges with staying current. So this was after the 2009 upgrade, but before our 2014 upgrade. So after the 2009 upgrade, we resolved some operational challenges, but then after time, we started to see some issues that were happening. The servers out there were starting to get to be at the end of their life. They were also starting to fail. The PCs on the plant floor for the HMI operation, those were still on a PC base. So this was very labor intensive from the maintenance department aspect. So each PC out there was individual per HMI station. You also had to load, it would take them up to about 8 hours a day just to load all the software that had to be on there. If one failed, you'd spend 8 hours just remaking one to reissue it back out. We wanted to combine the applications for fewer workloads, so we wanted to reduce the amount of physical hardware that was out there. The visibility was still limited. Like I said, we got some views into the process after 2009, but we still wanted to be able to see more, so we wanted to upgrade that in 2014. We had a high cost of maintenance. Due to all the server failures, the hard drive failures and what was happening, we were calling in contractors all the time, plus we were paying for all the equipment repairs that were happening out there. In a way, we were out there just firefighting, just trying to keep the plant up and running.
Yes.
The servers, when you went from the old homemade server, like a batch process to FactoryTalk Batch, did you install that on the old server?
No, it was new physical servers, but they were at the 5-6-year-old range by the time we did this. So we're seeing hard drive failures on those. Is it 9?
Yes.
9.
So the applications and operating systems, so the revisions, again, or the versions were not up to date, so that's where we had to juggle the production between upgrading.
So we put in a SAN infrastructure with a virtualized environment for them. Basically, it's a storage array network. So you have one large storage array and 2 hosts so that you can segregate your applications, load balance, and then make use of high availability and fault tolerance, which basically means if you lose one piece of hardware, your virtual image will fail over to the running piece, and then you can fix that other one, get it up and going, and load balance again. It optimizes your storage, and it also allows, with the virtualization, to back up those images so you have constant current backups of the entire virtual image. And we use a product called Veeam to incrementally back up all of those images and store it in offsite storage. So this is a diagram of their architecture. Rockwell best practices say that every application should have its own workload. So we're able to do this in the virtual world. In the physical world, it's too expensive to have that many physical servers. So with the virtualization, we're able to segregate everything as we need to. So we have a FactoryTalk directory, a pair of redundant HMI servers in there running the FactoryTalk View SE. We segregated out the I/O servers for the RSLinx Enterprise, and we're also running our Historian interfaces on those as well. So all they're worried about doing is data collection, no combining on other servers for that. The terminal servers run the client applications. It's a thin client architecture, and we're using Thin Manager to manage both of those terminal servers for the HMI applications on the plant floor. We have a Historian SE server, FactoryTalk Batch, the Vantage Point server as before, as well as a pair of domain controllers. We use Active Directory tied directly into the FactoryTalk security for ease of management of groups and users throughout that system. The engineering servers are what we use for remote access for both Esden's group and as well as ours or other vendors. So you have a place that you can remote into, access the PLC and HMI programs in one secure site. The backup server is the physical piece of hardware, and that's what, when Veeam runs on the virtual system, it will push all those incremental backups to that backup server. It's just a NAS, it's storage basically. Wireless is being implemented on the plant floor. It's actually connected to their corporate network, but then from there they can route right into the engineering servers and troubleshoot on the plant floor using their tablets to troubleshoot devices, see what's happening, because in a dryer application, you go up 90 feet, you don't want to run all the way back down to look at an HMI to check something out. Okay, we're going to go on to some of the benefits now. The first one is the visibility that they were able to get. A big one is a view of the operation by maintenance, both using FactoryTalk View SE, Vantage Point, looking at trends, as well as Thin Manager. They're able to do a lot right from their desk, where before they were running out to the plant floor trying to troubleshoot on the fly. Again, I just mentioned the tablet usage that they have on the plant floor. They're far more efficient when they're able to do that. We're collecting energy data now, so we're able to get visibility into the usage that the plant has for water, electricity, and gas. And then process. By not focusing on just keeping the plant running, we're able to look at this data and make additional process improvements to increase the production even further. The remote support has been invaluable for both us and Esden's group. If Esden's at home, he doesn't have to worry about jumping in his car, running to the plant to maybe fix a problem that can take 5 minutes by just logging into the system. So with that, we're able to troubleshoot in advance, find problems before they happen, and we're doing that by use of emailed reports, both production reports and reports directly from the VMware stack that gives us information on CPU usage, if there's any hard drive failures or anything. We'll get those alerts, and then we can react to them ahead of time before they become problems.
So now continuing on the benefits. So the migration to batch with the scheduling application. So with this, the scheduler no longer has to go out on the plant floor 3 to 4 times a day. They still will go out there to do their normal checks, But with that, they can be on the phone with corporate or on a conference call, whichever it is, and they can look directly up on that web page server and see what batch they're currently running on, how many more they have to make, and they can make decisions right on the fly of what we need to do. So they have the view directly from the office on what's currently being ran. We also have the view from the maintenance department as well. We had a batch time reduction of 10 minutes per batch, so that's huge for us. 10 minutes might not seem like a lot, but when you're only talking about a batch that takes 30 to 40 minutes to make, you're cutting off a huge amount of time. That's roughly a third of the time it took. We cut off a third of the time. We're also able to increase the batch sizes. So before, what they had to do is our slurry kettles, they could only fill them half full because then it feeds to our surge tank system that feeds our dryer. They could only make a half a batch in enough time to physically transfer it all over to keep that surge vessel running, to keep the dryer running. Now we're able to optimize that, fill the batches completely full, and continue to keep the process running. Operational efficiencies with FactoryTalk View SE. So now we only have to make changes in one spot. We can make one change, save the page, have them click back and forth, refresh their screens, and then they have the new upgraded graphics that are on there. We've had to do this on the fly before, and it's been a great advantage for us. We can add anything, any type of graphics or logos, save it, and they have it. We saw a 6% increase in production over the past 2 years. This is huge as well. Years prior to this, we would roughly see about a 1% to 2% increase in production. So 6% in 2 years is huge. Like I said before, we have a sister plant that allows for us to have some healthy competition with them. With the 6% increase, it allows for increased capacity in the whole entire division. So we're able to take on more powder at our facility, produce it at a lower cost per pound, and then take more away from that other facility, allow the sales team to fill up that other facility as well and sell more product. So continuing on the benefits, the visibility using FactoryTalk View Vantage Point. This has been a huge help for us in the maintenance department. With that, we have the use of daily production reports. So we have an automated report that gets emailed out every 12 hours and every 24 hours. The 12-hour shift report is used at the 10-minute meetings where production does their handoffs to the next oncoming shift. And then at the 24-hour one gets brought up at the morning huddle. So all the management team comes in for the morning huddle. We review the last 24 hours of production, see if there's any action items that need to come out of that, assign tasks, and then continue to move on from there. Energy usage. We can now break down our energy usage on an asset basis. So we can dive all the way down into a pump, fan, motor, whatever it can be, and break down and see how much energy that asset out in the system is using. Batch and cleaning reports. This is huge for our sanitation manager. He can now print these out and see where they had operational inefficiencies in the cleaning. Anytime we're spent CIP, and it's time that we're not making production. And then efficiency reports, which correlates into all of these. Visibility of the plant operation using Thin Manager. This is used on a daily basis. I think each day that we come in the electrical and utilities department, those guys are loading up the Thin Manager. That way they can see and view all the screens that are out there. With this, we're able to shadow and view the sessions. If any maintenance guy gets a call, he's able to go on, look at the screen with the operator while he's on the phone with them. If it's an operational issue, he can try to correct that operational issue at that time. We are a food and beverage, or a food manufacturing facility. So with that, we have donning and doffing stations all over in the facility. If you have to go through 2 donning and doffing stations, that can take you up to 8 to 10 minutes longer to get out there. With this, they're able to see the view of the screen. If a pressure, temperature transmitter, anything else like that has failed, they can see it, look it up in our CMMS system, walk right upstairs to our parts room, grab that part, walk out on the floor and replace and get operations back up and running. So continuing on, so this is what our automatic shift reports look like. So this would be an example of the 24-hour shift report. The 12-hour shift report is a little bit more condensed. It doesn't have the graph on the side because what they're trying to do is just provide that instant information to the next oncoming shift. So this is what we review at the morning huddles. With that, we have our dryers. We break it up by per dryer. We have our production code, and we have our runtime and downtime hours. The pounds per hour is huge for us. We never used to have that on there. Before, what we had was an Excel spreadsheet where they would type in their overall average for the 12 hours. So with that, you could have a good first 6 to 8 hours. The last hours of your shift, they could do very bad or slow down the pump to take it easy, and you would never know. We now have a running trend of that, so we can see into it and say, hey, why did at 1 o'clock, why did the pump drop down, and what happened in our process? So it brings up action items, again, at the meeting. It also allows us to correlate it. So like right here, we have our quality measures. So this is just one of our quality measures. We have several other ones, but we can see how close they're running to those lines, our upper spec limits. If they're getting too close to the spec limits, it could allow us to say, hey, that's why they slowed down the pump, or that's why they made these operational changes, and that all makes sense. So continuing on, we have performance. So per dryer, we have our natural gas usage. We can break that up to our line efficiency. So based off of how many pounds of product we produced, we can see the gas ratio on that. We also have the water usage on there. Then we also have a trends page for the natural gas usage. This just allows us to zoom in a little bit closer, see how the natural gas is flowing. The graphs on there also auto scale. So we have one on the right hand, for instance, which is 0 to 250, and the other one is 160 to 195. So the dryer one at that time stayed up and running for the whole entire 24 hours. The other one went down for a shorter time frame for a CIP or product changeovers, whichever it is. The water flow, we use this mainly for our CIPs, but we also use it for when we're not CIPing. We can see how much water we used during our CIP and based off the last one. So with that, you can see if a rupture disc is broken, if a valve got locked open, or if you have water going down the drain. So it allows us to see it for the CIP, but it also allows us if they're not CIPing. So if we know for a certain time instance that nothing else should have been going on in our process, and we see a huge spike in our gallons per minute, we can dive into that as well and see why there was a bunch of water going down the drain or in the process. So continuing on in our benefits, so now we're able to have real-time information to make real-time decisions. So we can take the data that we're now getting back and make the best educated decisions possible for our facility. We've seen a maintenance cost reduction on equipment for spending on repairs. So without all the hard drive failures, without calling in all the contractors, with being able to support it with our own on-site staff now, we're able to reduce our costs there. We had a downtime reduction in just automation alone. So by automation, this gets put in by our supervisors. They put down in our downtime based off of the reasoning code. With that, in 2013, before our 2014 upgrade, we were at 49 hours of downtime in automation. In 2015, we were at 14.5. So that's 35 hours that was given back to the business just through that upgrade. The downtime reduction also allowed maintenance to focus in on the true asset reliability. So with that, we're able to break up the maintenance department into other tasks instead of having them out there running around like a bunch of firefighters just trying to put everything out and keep our plant running. We have a stable system now, so we can get them supported and localized in what they need to do. With that, we were able to give 11 days of total production back to the facility over the last 2 years.
Okay, now we're going to talk about some of the next steps that we're planning with Land O'Lakes here. And one of them is just continuing to use this visibility to keep troubleshooting, and by putting together a plant model within Vantage Point, we can focus on the different areas of the plant and do troubleshooting directly over the phone together. So this is an example of an ad hoc trend that Ezra and I put together when we were troubleshooting the line. We're identifying a problem that was occurring, but no one was there to see it happen. So we figured out the parameters we needed to put in this trend, and then when we knew it happened, we were able to drill down right down to the 5-minute area and see what was occurring. So this allowed us to focus our troubleshooting efforts together over the phone without having to run through the plant and find a solution to the problem. Energy. More analysis of energy is happening on a daily basis. This is an example of some electricity energy monitoring that's happening. The dotted line is the pounds per hour that's running, and the bars show the different electrical usage of some of the motors that are running the operation. So through the production, you can see which ones are using more energy, less energy, and you can correlate that to previous days. So if you see one motor is all of a sudden trending higher and higher as it goes, you maybe know that a bearing's going out. Something is happening in the process that you need to focus on. Or if you see one is continually using higher amounts of energy, maybe it's time to change that over to a VFD and reduce that energy usage. With the SAN system, we're able to implement, we put together some software support where we monitor the system. Along with getting all the emailed reports from it, we do a system health check once a month for Pine Island where we look into the applications and the hardware to see if there's any danger points within the system. And we produce this report for them. So first of all, we look at the applications. Is there anything within the FactoryTalk View system, some errors being logged that need to be fixed? Are there tags in Historian that are bad for whatever reason? Maybe they got deleted or something happened that it's not needed anymore. We can just remove them from the system. We look at the storage array, make sure that all the disks are healthy, the system's running normally. We look at the switches and networking. We do some analysis, see if any packets are being dropped, if there's anything that's a delayed response time, so we can focus on that area to see if something was plugged in we're not aware of. System check, the UPS. We have smart UPSs on the system, so we can look into the batteries and see if the battery life is healthy, because a UPS with no battery is of no use to anyone. Thin Manager, we look into there to see if there's been disconnections of sessions, to understand if there's a problem with maybe a network or a thin client, so we can address those. Veeam, that's the backups of the different images, and we can see if there's one that's failing and maybe there's something inside there that requires some work so that it will continue to back up. The VM overview, we just check, make sure that there's plenty of hard drive space within the VM itself. If there's an application that might be storing too much data or whatever, you don't want your hard drive to fill up and stop the applications. That creates downtime. And then the hosts themselves, we just look at the CPU usage, the RAM, make sure that everything is running good. If we can look at this from an hour, a day, a week, or a month, and maybe if we see a high spike, we can determine that maybe updates were occurring or another process, and allow us to focus on that to make sure it's not a problem. So finally, the information we're able to gather, we're going to keep gathering this information and then prioritize all the repairs that are needed on the plant floor, so they're not being reactionary, they're being proactive. We're putting plans in place to remove the rest of the legacy I/O that's on the plant floor so that it can get all to Flex or Point I/O for remote I/O. Looking at the data, we can continually optimize the process. They've been working on that to get more efficiencies in the dryer and create more volume. And then training with the visibility that's there, Esden's group in maintenance, also the operations, they can take a look at the operation that's happening using Thin Manager, watching how operators run the system, or from a maintenance standpoint, see everything that's happening on the plant floor without having to go out there and just learn on the fly. So training gets a lot quicker, and you're able to put people on the floor that are ready to go to work. If you could, we'd love you to fill in the survey on this. Let us know how we did. And I appreciate your attention. Are there any questions that anyone has? Yeah.